Welcome back. Today we're going to learn about this concept called subsets. Up here I have two sets, set F and set G. Set F contains the elements Adriana, Precious, Dayton, James, Devin, and Haley. Set G contains the elements Adriana, Precious, and Haley. We can say set G is a subset of set F. So what does this mean? This is the new concept we're going to learn. Set G is a subset of set F. So I'm going to give you the definition of a subset. We say set A is a subset of set B, and the symbol for that is a little U on its side. So if you ever see that symbol, you read that as subset. So what we have below is A is a subset of C. Up here in this example, we can say G is a subset of F. So what does it mean to be a subset? Well, set A is a subset of B if and only if all the elements of set A are also elements of set B. So everything in set A here, it should have been a B, not a C, has to be elements in B. Up here, if you look at this example, everything, all the elements in G have to be elements in F, which is true. Adriana is an F, Precious is an F, and Haley is an F. So everything in G is also an F. All right, example 1. Determine whether set A is a subset of set B. So take a minute to think about whether set A is a subset of B in each of these examples. So if we look at example A here, I want to know, is A subset of B? Is A subset of B? So we need to ask ourselves, is everything in A, which is apple, oranges, and grapes, are all those elements also in B? Apples, oranges, and grapes. So yes, we can say A is a subset of B. This is true. A is a subset of B. Well, let's look at example B here. Example B. Is A subset of B? We want to know, is this true? Is A subset of B? Again, look at the elements in A. Are all the elements in A also elements in B? No, they're not. Because in A, we have the element 2. It's 2 contained in B. No, it's not. So all you do is just find one element. All it takes is one element to make it not true. So we could rewrite this as the following. We'll use the subset symbol, but we'll put a slash through it. So this says A is not a subset of B. A is not a subset of B. That's what that symbol means. Okay, this is just a little quick review. You've seen this before. These are the different sets of real numbers. If you look at the natural numbers, everything in here is also the whole numbers. So what's true is the natural numbers is a subset of the whole numbers. Also, everything in the natural numbers are also elements of the rational. So we can say the natural numbers are subsets of the rationals. And again, the symbol for rational is a cube. What's not true is this. The integers And the symbol for integers, again, is z, is not a subset of the whole numbers. If you look at that, is everything in the integers also in the whole numbers? No. Okay. This note at the top of this screen is very important. There's two sentences up there. They're extremely important for you to remember. The first sentence says, every set is a subset of itself. This is always true. Every set is always a subset of itself. And then the second sentence is also true. The empty set is always a subset of every set. So I want you to always remember that. And then down below here, I just have a theorem. It says this. If A is a subset of B, and B is a subset of A, then what's always true is A is equal to B. Okay, let's look at this example. I want you to determine the number of subsets that each of these sets have. So the first set I want to look at is the empty set. The empty set would be the set that has no elements. So how many subsets does the empty set have? One. Has one subset. The one subset would be the empty set. The empty set is the one subset of the empty set. All right, let's look at a set that has only one element. So let's just make a setup. Let's say it has the element C. How many subsets does it have? It has two subsets. The two subsets will be the empty set and the set itself. As remember, when the empty set is always a subset of any set, and the set itself is always a subset of any set. One more example here. Let's say I have a set that has two elements. The two elements are A and B. How many subsets does this set have? Well, this set would have 4 subsets. I will list them out so you can see them. The 4 subsets would be the empty set, the set itself, so the set that contains A and B, and then it has 2 more. The last 2 subsets would be the set that just contains A and the set that contains just B. These are the 4 subsets of that set AB. Okay, here's a really important theorem at the top here. Write this down, take a photo of it. It says the number of distinct subsets of a finite set A is 2 to the n power, where n is the number of elements in that set. So let's go back and let's use this theorem. Let's take a look at this theorem and look at the examples that we have done so far. Okay? It's 2 to the n power, where n is how many elements you have. So if you look at the empty set, how many elements does the empty set have? 0. There are no elements in there. What is 2 to the 0 power? 1. So it has 1 subset. Or if you look at this example, this set here had 1 element. So that would be 2 to the first power, which is 2. So it has 2 subsets. If you look down here, this set right here had 2 elements, A and B. That's 2 to the second power. 2 to the second power is 4. So it has 4 subsets. All right, final example. Example 3 here. It says determine the number of subsets that the set LABE has. So let's use this theorem. It's 2 to the n power, where n is how many elements you have in that set. How many elements do we have in this set? 1, 2, 3, and 4. So this would be 2 to the 4th power. So 2 times 2 times 2 times 2, which would give us 16. So this set here has 16 subsets. I will show you the 16 subsets to prove to you that it actually has 16 subsets. Here are the 16 subsets of that set. Again, we always have the set itself, and we always have the empty set. These are always two given subsets that you should automatically know. The set itself and the empty set. And then here will be the other 14 subsets.